Welcome everyone to Knox Game Design for August 2024. My name is Levi Smith. So this month I'm going to be talking about blockchains and how that can be used for game development. So to start out, what is a blockchain? Why would we want to use a blockchain? We can use it to track things like currency for online games, validate ownership of items that can be either weapons, armor, or any other type of items, or currencies such as gold within game, GP, gil, rupees, whatever, buckazoids, things like that. And it's also a way to ensure that in-game items are unique, especially if you're doing an online game. And you can also limit the number of items that are created for that game to create scarcity to give more value to those unique items. So this is basically what a blockchain is. It relies heavily on hashing. Hashing is kind of like a digital fingerprint for a set of data, a string. So in this example, I'm going to be using PHP. PHP has a nice function called hash, which hashes for you. So it's going to take a string of data and then compress that down into a set of characters using the SHA-256 algorithm. So it's pretty nice. You don't have to write that yourself or use any external library. And then we're going to pass in an input string. So what do we need? What is a blockchain composed of? It's composed of multiple blocks. So what does a block have? Well, in this example, we're going to have a timestamp when that block is created, the data which goes in the block, and then a hash value of that block, and then the hash of the previous block. And then in the blockchain, all it's really going to be is an array of block objects and then some additional methods. So this is basically what the block class looks like right here. So I'm really not going to be using the index. But we will have a timestamp, the data for the block, the hash value, and then the hash of the previous block. So we're going to have a constructor which takes those values in, and then we're going to assign those to the instance variable. Then when that's done, it's going to calculate the hash of that block and store it in the hash value, and then we have our block created. We're not going to worry about the previous hash right now, but we do have a calculate hash method right here. So that's basically going to concatenate that index value, and I ended up taking the index out. So basically it's going to concatenate the value of the previous hash, the timestamp, and the data. Then it's going to calculate a hash based on all that. And then we're going to store that in the hashed value. We're going to return that hash value and then store that into the hash instance variable right there. That's basically all there is to a block. So in the blockchain, like I said, we're going to have a variable called chain, which is basically just an array. In the constructor, we create a new array. And then in that array, we're going to place what's called the genesis block. That's going to be the first block that's created, and basically it's going to use a set date that we specified right here. I'm going to use the RFC 3339, I believe, format. Talk about that in a minute. So it's going to return a new block. We're going to call it the genesis block. And then we're going to have a few helper functions, get the latest block. So that's just going to return the last block on the chain, and size of chain -1. And then we're going to have a function to add a block. So that's basically going to use array push, and pushes a new block onto the chain. So yeah, here's an example right here. So we're going to create a new blockchain, and we're going to get the current timestamp. So we're going to add a new block. We're going to pass in the current timestamp, the string hello, that's going to be our data, and then the previous hash is going to be get latest block hash. And then once we have that, we're going to push that onto the blockchain using our add block. Then we're going to create another block and with foo as the data. Then we're going to add that to the blockchain right there. Then we're going to create another block. We're going to have bar as the data. I'm going to add that to the blockchain. And then finally, we're going to have Baz, and we're going to add that to the blockchain. So then at the very end, we're just going to print out that blockchain within these pre-formatted HTML tags. So this is what it looks like in PHP over here. It creates this PHP object, which is an array, and we have our 5 blocks to 4 that we added, and the Genesis block is the first one. So you can see for the hash value right here, it creates this long string of hexadecimal characters right there. So that's the hash of these values concatenated together. Then for the first block, you can see here, we got hello right there for the data value, the timestamp, and then the hash, and then we got the previous hash right there. So it's going to take all these values, concatenate these together. So it's basically going to look at the block before it, pull in this CE067, set that as the previous hash, then take a hash of all that, then assign it to the hash value right there. And then it's going to do the same thing with the next block, which is foo for the data. And you'll notice that the previous hash equals the hash of the previous block. And then the same thing for bar, and the previous hash equals the hash of the previous block. And then finally we've got Baz here. So it's all kind of linked together through those previous hashes right there. So then we're going to have a method called isChainValid. So it's going to start at block index 1, and we're going to get the current block and then the previous block. So we're going to, for each block in the chain, we're going to validate that the current hash is correct by recalculating the current hash. If any of the blocks hashes are not valid, then it's going to return false. And then it's going to look at all the previous hashes. And then if any of the previous hashes are not valid, then it's going to return false. Otherwise, if everything's okay, then it's going to return true. So what this does is it ensures that none of the values, any of the blocks on the blockchain have been tampered with. Because if for a block you go in and change the data, then when you calculate the hash, then that hash isn't going to match what the hash value is assigned in that instance variable, because you changed the data, which is a part of the hash. Also, if you go in, if you do recalculate the hash, and then assign that to the current hash value, then it will be valid. But the next block's previous hash will then be incorrect because you recalculated the hash of that block. So the next block's previous hash is going to be invalid. So it's just a way to ensure that everything's has data integrity. Some people call this like a ledger, where you just keep track of every single or every all the data and all the hashes. And I'll show in a little bit how that can be used in a game. So here's some of the recommended standards. This is when I was talking about this ISO AEG 601, RFC 3339. That's what I'm going to be using for the dates. It's a nice format for storing dates. It captures the day, month, and year, and also the timestamp. And it also has the time zone code. Either like UTC is 0 hours off, or if you're on Eastern time, then it'll be, I think it might be -5 or -4, whether it's daylight savings time or not. So this format's supported by PHP, which is nice, and it's all one string, which is nice. The one nice thing about this is it eliminates the daylight savings time issues. You don't have two AMs or 1 AMs on during the daylight savings time change. Another thing I use is this UUID, which is the universally unique identifier that can be used for assigning like a unique ID for an item, a weapon, a piece of armor, whatever in your game, and it's pretty much guaranteed to be unique every time you call that. It's a really long string, and it uses part of the uniqueness from the system itself, and then part of the uniqueness from the current timestamp. So between those two, and it ensures uniqueness in that UUID. So even if you have two of these created on two separate systems at the exact same time, then the UUIDs will be different because of that portion that it pulls in from the system, the system ID. Yeah, so it can be based on a MAC address or something like that. It's not a physical hardware property. It's also known as a GUID, I think, on Windows. There's a built-in Linux command called UUID gen if you want to create a UUID from the command line, which is what I use in PHP. Yeah, there's no standard UUID method in PHP, so I just call UUID gen within PHP. So how can a blockchain be applied to a game? So in that data field, we can just go in and start. I end up actually creating a new array for the data, so you can give it a name, like a weapon, like a stick, and put in the cost, attack. Now this is something I'm went back on, is like the owner. That might actually just be captured in the transaction. So I think we want to get rid of owner equals admin right there, but I just hadn't updated the slide. And then get rid of the ID right there. You could have the ID be the UUID, but actually you'd put the UUID within the data structure as a part of the data and not as a separate item in the block. So we got like a dagger for cost 1,000 and attack value, and then a short sword for 3,000. You got to watch out for some of these things. Like I had a parsing issue with short sword with a space in there when I was parsing that out. Has an attack of 4. Then a long sword costs 10,000. That can be gold or silver or whatever your game's currency is. Attack value of 8. And that's our blockchain right there. So how did I implement this? So this is my development environment right here. So I'm developing under Windows, just like Windows 10. Windows OS, so that's got a internal IP right there. So I'm developing this within Unity on my Windows box, but I need to have a way to go out and grab this blockchain. And then instead of having it also running on Windows, I actually set up in VirtualBox a VM with Fedora Linux, which is part of Red Hat, or I can't remember if it's upstream or downstream. But kind of like a dev version, community version of Red Hat Linux. I think it eventually gets fed into the main Red Hat build, but it's going to have a similar but different IP, 1.18. So on our Fedora VirtualBox, we're going to have Apache running, so that's what's going to serve our blockchain. And then PHP running right here. So I'll go ahead and mention it now. This is kind of like a centralized blockchain right here. If you look at a lot of the stuff online, a lot of blockchains are set up not centralized, kind of like using a peer-to-peer, where it's distributed out to many different systems, many different nodes. I'm not going to be doing that for this example. This is just a proof of concept, just show how it could be implemented in a game. But yeah, if you were to do this for a real game, you may want to do something non-centralized and have it. But then you get into a lot of other issues, like keeping all the blockchains in sync and in agreement and things like that. So yeah, we've got a VM set up for client game or for the server. And it's just a nice way to keep the server stuff separated from the client. You can find the IPs using ipconfig under Windows or ifconfig under Linux. And the PHP code is in var www HTML blockchain. One thing that I was just going to mention here, when you're setting this stuff up under VirtualBox, it's not too hard to set up. Fedora or any Linux, after you get the ISO, getting the networking can be a little bit tricky. You got to use this bridged adapter. There's some other ways to do it, but I find using the bridged adapter is the easiest way. So that's a way to get it at the HTTP running Apache. And then you also have to modify the firewall. So we're just using, for this proof of concept, for this demo, we're just going to use port 80, standard HTTP, no HTTPS, anything like that. But you do have to run the firewall command and add that port 80 to allow it through the network, well, back to the Windows OS. So here's our VirtualBox right here, and you can see I have some other Linuxes and other stuff installed, but yeah, I got this Fedora right here. That's going to be our little server. So it's just a nice way, if you don't have a development server, to just like set it up on the system with it being a separate Linux instance to connect to. And you can see it right here. So this is where I have the code of our www.html blockchain. You can actually see the status, like you can do a systemctl status of HTTPD. You can see that Apache is running right here. Started up, you use the enable command, system control enable, to start it up when Linux starts up, when the OS starts up. So, and like I said, do the firewall command, make sure that it allows this back through. So once you have this running, like if I go up, let's see here. So if I do a cat on index.html, I just have a little hello world right here. And what's cool is I can go back to my Windows operating system, the client, and go. So if I run ifconfig right here, I can see the IP address is for this one 192.168.118. So if I go in a web browser to HTTP no S, like I said, this is just proof of concept demo, and do that, you see our hello world right there. So I'll put the code out online, but I kind of just like walk through the different steps. So I started out with blockchain 01.php, and here we have our block right here, and our calculate hash right here, and then our toString just for printing debug, and then our blockchain right there, and add block, and here's our is chain valid to validate our blockchain right there. And then just our test cases with the hello foo bar and all that right there. So I think what we can do is see if we can do PHP blockchain 01.php. So yeah, that just goes in and runs that with our example code. Then it prints out our blockchain object right here. All the hashes and data and all that good stuff. Right there. So I kind of just go through the different steps of blockchain 02.php and see what was this doing. So this is kind of the same. This is where it creates our Genesis block right here. And then we added our get latest block and add block. Is chain valid. Oh yeah, and this is where I added the weapon information, like a stick and dagger, cost and attack right there. So if we do PHP blockchain 02, then we see now in our data we have, yeah, and I actually fixed it, so we actually have our data within like a JSON array. Actually, there should be square brackets around those right there. Be proper JSON. But that's okay for now. Blockchain 04. Yeah, so this is where I got rid of the index out of block because we really don't need it. And by the way, I'm completely new to the blockchain, whatever you want to call it, technology or way of programming. So I found a demo online, which I'll put a link to it, but it's like the basic JavaScript blockchain. And so I basically kind of adapted that for PHP. So that's where I got a lot of the, I guess, algorithms for implementing this. Let's do that example. So yeah, that's where we're valid. Okay, so for blockchain 04, this is where we're actually writing it out to a file, and then we're JSON encoding. So we're going to take the PHP array object, blockchain object on all the blocks, and we're going to write it out to a file using JSON encoding. And then we're going to display that out. So here it says reading blockchain, writing blockchain, and then that's going to put it in our data JSON file. So I can do PHP blockchain 04.php, and then that's where it's going to put out all this, reading blockchain, writing blockchain. That's not JSON, but I think we can go into our data. Let's look at blockchain. So yeah, that was just now. So vi blockchain.json. So yeah, it's going to put it all in one big JSON chunk right there. But what we can do is we can go to 192.168.118 blockchain data blockchain.json in our browser, and here it is right here, and it's still kind of clumped together, but we can do pretty print right there, and then it's going to put it in a nice formatting where we can read this right here. So we can see here we got our Genesis block, the hash is 3EO blah 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 blah. It has no previous hash. For the next block we got our stick, cost and attack. You can see its hash is 8CCA, but the previous hash for it matches the hash of the previous block. And then the next one for dagger, we got a hash of 527, blah, blah, blah. Then the previous hash is 8CCA, matches the hash of the previous block. And the same for the short sword, and the same for the long sword. So just verifying that the previous hash matches the hash of the previous block for all of these. Then finally, we got blockchain 05.php, kind of the same thing going on here. Let's see here, you can get latest block, chain valid, write to file, display. So yeah, this is where I'm actually creating an array out of the weapon data right there, instead of having it just as one value. Oh, and this one I add the transactions. So that's the next step. So once you have the items, you need a way to show that an item has been purchased by the player. Oh yeah, this is just like 5,000 gold just to get started, just to start the game off. So I have like admin, so all these items are just kind of created out of thin air. So you need like an admin user or a bank or a marketplace, some like point of authority. An account like is the point of authority for creating items and any new gold or currency in the game. So yeah, that's just giving the player 5,000 gold just to get started for something, just like signing up and playing the game. So here's a transaction. So we have from LD Smith, so that's just like a user account, say in my game, to admin. And then we're going to give 200 gold. And so we're going to create a new block, add that to the blockchain. And then in the next transaction, we're going to have from admin to LD Smith, item ID 0. So yeah, this is just a demo. In a later version, I actually went in and changed this to a UUID, which would actually be a better identifier than 0, 1, 2, 3, 4, but we're just going to use 0 for now. So we're going to create a new block with that transaction data and add that to the blockchain. Now, really, probably what you'd want to do is have a block with 2 transactions in an array. So you verify that both of those transactions went through at the same time. The player gives the admin, how much gold was it? 3,000 gold or 200 gold. Then at the exact same time, the admin account gives the player that weapon with that identifier, that UUID or whatever it is. In this case, we're just using 0. So just to verify that both of those went go through at the same time. So then we have another transaction. We're going to have LD Smith send the 3,000 gold to admin. And then we're going to have admin send LD Smith the item ID 2, which is, if we look further up in our blockchain, ID 2 is the short sword. So in this case, the player has bought the stick and the short sword. That gets set in 2 new transactions and gets added to the blockchain. We'll do PHP, blockchain 05, PHP. So that creates this, creates the same blockchain. And then we added those transactions. So you can see here from admin to LD Smith 5,000 gold. That's just to get started. As I mentioned previous, so we get a hash for that, and then we set the previous hash. Then we have the transaction to buy the stick from LD Smith to admin, 200 gold. Then we have another transaction from admin to LD Smith, the item with ID 0. And then here's where the player buys the short sword from LD Smith to admin. We're going to send 3,000 gold, and we're going to calculate the hash, set the previous hash. Actually, the previous hash gets added as a part of the complete hash of this. And then admin's going to send LD Smith account item ID 2. And then we're going to calculate the hash based on the timestamp, data transaction, and the previous hash. So that should have created in our data folder, because we wrote it out, blockchain.json. So it should, yeah, here it is right here. Previous hash, long sword, and all that. So I actually did a kind of a pretty print on this already. We can go back here. No, what is it? Yeah. There it is without the pretty print. That's it, where it is with the pretty print. So yeah, from our Windows box reaching into the Fedora running VM, then we're able to pull all these transactions in the blockchain, and then we see where the account LD Smith has bought the stick and short sword from admin, and for 200 gold and 3,000 gold respectively. So yeah, let's go back to our slides right here. And this kind of just what I'm showing here. First thing you want to do is verify you can go in with your web browser and see the chain right there. And so if we want to get the blockchain in Unity, this is what we do. So I created a blockchain C# script. We're going to import Unity Engine Networking. We're going to create a get blockchain method. That's going to return an enumerator. So that's going to make a Unity web request, www. Then we're going to get the URL of the blockchain, which is defined right there. And then we're going to yield and return www send web request. And then the results are going to get set in a byte array, www.downloadhandler.data. And then string blockchain gets the value of www.downloadhandler.text. And then we're going to print out that blockchain right there. So we're going to assign that script to a blockchain game object. And then we're going to display the outputs of the blockchain in debug.log. So let's go back and go to Unity. So here's, I already had it pulled up right here. I'll go ahead and clear it out right here. But here's our Unity right here. So I got our blockchain. I actually had a blockchain, like one or initial blockchain right here. Visual Studio. Yeah, so this is like the first iteration right here. And then I have the blockchain 02, which added a little bit of additional parsing, some additional functions right here, which I'll talk about in a second. But yeah, the part of just getting the blockchain is right here, and get display blockchain and get blockchain data. So that's going to display it out to the debug console right there. So if we press play, like I said, that blockchain, actually blockchain 02 script gets assigned to this blockchain game object right here. So when you run it, you're not going to see much. It's just going to say chain. It's like, hey, where's the data at? Well, it only displays that first line unless, but you got to click on it right there. So once you click on it, and then in the display down here, you're going to see that same chain, which we saw in the web browser. So here's our items: the stick, the dagger, the short sword with the hashes and previous hashes, long sword. And here's our transaction. Admin's going to give LD Smith 5,000 gold just for signing up. Then LD Smith is going to purchase for 200 gold the stick, which is ID 0, item ID 0. Then LD Smith is going to send admin 3,000 gold to purchase the short sword, which is item ID 2. And so for each one of those, we're going to calculate the hash of each one, and then and set the previous hash for each one. So that's what makes the blockchain valid. So it's a lot better than a lot of games, because a lot of games, everything's just like in a database, and there's no accountability. There's not like a ledger or anything. Like items can just be made up out of the blue and assigned, and items can be taken away from people or given to people just by updating the database. But with this blockchain, it ensures that every transaction is valid. I think they call it like immutable. It can't be changed. So what I did is I added those additional methods in here. So if we want to get the money for the player, we're going to go through every single block in the blockchain, and where money is being sent to me, what I'm calling my LD Smith account, for every transaction in, we're going to add to iMoney received. And then for all money sent, we're going to add that to iMoney sent and take the total of all those. I'll go ahead and mention one thing that isn't being done is validating transaction. And if you look at like Bitcoin, that's how Bitcoins are created, by people, miners, validating transactions. So I'm not going to get into that in this video, but there is a case for these transactions needing to be validated, because in this case, somebody could actually spend more money than they actually have, and this would actually allow it. One thing I want to mention is when I'm parsing through these blocks, I'm just using a regular expression. The default JSON parser in Unity is really sad, not very good. It only parses like at the very first level of an array. You can't do with like values within a subarray. So that's why I'm just doing this with a regular expression, matching on my user account and like gold value. Really, there are libraries, I think, like Newtonsoft, and I really didn't take the time to learn Newtonsoft and everything. JSON parser, that's probably a better option. So we got the players, how much gold the players received, how much gold the players sent, and then we want to get the player's items. So I'm going to do additional parsing to parse out all the items that have been sent to my LD Smith account right here. So where it's from ID anything, that's what this is saying right here, to ID LD Smith, and then here's where it's capturing the UUID of that item. I thought I went to 5, but I may have done 6. Yeah, blockchain 06. So here's blockchain 06 right here. So basically what this is doing, it's okay, so yeah, right here. So we're doing an exec in PHP on the UUID gen system command to generate a UUID and assigning that to ID. So now we got a weapon array. So ID is going to be the value of that UUID gen generated UUID. So every time you call an exec, it puts it on like a stack or an array, puts it at the end of the array. So to get the latest UUID gen, you just do ID count ID -1. So what this is going to do, and then I have to do a little bit of trickery right here to go back and get those UUIDs when I do the transactions. That's what that's is for right there. So let's go back and do a PHP blockchain 06. Okay, so now if we do a cat on data blockchain JSON, you're going to see now, go back to the top, when we create the stick, it's going to have this ID with this really long string. That's our UUID right there. And then the ID, here's our dagger where the admin's creating the dagger. And then it's getting assigned that UUID right there. And same for the short sword. And same for the long sword. So then when we're doing our transaction, that's just where the player's getting 5,000 gold. But where the player's buying the stick for 200 gold, doing from admin to LD Smith, item ID is A453D21C, blah, 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 for item ID. So if we go back and look at the stick up here, then the ID is should be the same. Let's see here. Yeah. A453. Is that right? A453? Yeah, A453. So this is where the player's buying the stick. And the player sends admin 3,000 gold. Then he gets item ID from admin to LD Smith, item ID 689A. So 689A is the short sword right here. So yeah, so it all links together. So what we do is we go in here, we'll stop it. Yeah, so let's go back to our browser, click refresh. So you'll see now on our blockchain, we got the UUIDs for each of the items, each of the weapons right here. ID, UUID, and the same thing. This is what we just looked at with the transaction from admin to LD Smith. There's the UUID right there. And you can see that if we run this, you can see where Unity pulls in. Now it has the UUIDs for each right here. UUID, UUID. So this is the same thing. It's just pulling it in with the web interface call. So now if we look at blockchain 02, we're going to have get item. So it's the same thing as the get money. We're just going through and seeing all the items that have been sent to the player. So now the one thing this isn't doing, this is just checking to see anytime an item has been sent to the player account. What it's not doing is seeing if the player account has sent that item to somebody else, like where you can buy the item in game, then sell it to somebody else. So it doesn't do that yet. So that's where we're getting the items right there. And then this is getting I think this is just for getting what item is for a specific UUID right here. This is kind of like a helper method right here. So once I get the UUID for that item saying my LD Smith account has bought this item, what is the data, what's the property of that item? So it gets the UUID, the name, the cost. I don't even know if you really need the cost in here, but the attack. Now, if you're smart, if you're clever, you could probably even embed like JSON picture data in here. So if you have like an icon of your weapon, then you could probably embed that in another field. That'd probably be pretty slick. Or even if you had like a a model. You could probably even embed model. I don't know if there's a limit. I know like on some blockchains there are limits on the size, but you could embed other properties within this item right here. So with all that being said, if we press update display, you can see right here, money 1,800. That's 1,800 gold. So we started out with 5,000 that we got for signing up to play the game, and then we bought the stick for 200. So 5,000 minus 200 is 4,800. Then 4,800 minus 3,000 for the short sword is 1,800. So it correctly counted the amount of money we have left, and it also shows items. This item right here, the 453, has an attack of 1. 689A has an attack of 4. And I thought I had it where I actually even displayed the name, but that's not showing up right here for some reason. I thought I had that working earlier. But you can get the name of the weapon, whatever other properties of the weapon or item as well. So taking that, if you had a game, you could create like a player object or a weapon object, game object, then assign these properties into that weapon object to use in your game. I think that's pretty cool right there. So yeah, basically I talked about this, displaying the blockchain. And there's a question, should the blockchain be on the client or the server? You could actually put the processing for parsing the blockchain on the server, and then just send the properties of the weapon or item to the player in a call. I guess it's up to you whether you want to have it on the client or the server. You could have just like API calls to return the player's item as money. But if you truly want it decentralized, then everybody should have a copy of the blockchain and then sync up all those blockchains together. Yeah, how much processing is required? And like, you don't want a ton of processing going on the server, so you may want to have it on client. How big will the blockchain become? Will downloading and parsing it be feasible? If you've got a huge blockchain, gigabytes large, do you really want the player to have to download that huge blockchain every time to play the game? So you may just want to have an API call, let the server parse the blockchain for you, and then send the information to the player. Yeah, so that's what I talked about, having a weapon prefab and assigning those values. So right now I have it just written out to a text file. I use JSON encode and fwrite to write to a file, JSON decode and fread to read the values. So yeah, whenever you decode it, then it just creates a standard class object instead of your block and blockchain object, so it doesn't directly load it back in. You got to play some like casting tricks to get it back the way it was. You could store all this in a database, which is probably faster, less processing, less parsing of text files. So what this comes into is like, it's really kind of like NFTs, non-fungible tokens, which are kind of popular, or were popular not too long ago, where people could claim ownership using the blockchain, using blockchain technology, saying, hey, I own this image. That's kind of what it is. It's also called like smart contracts, where I've seen like some sites use a blockchain as like, well, if this condition is met, then execute this code. So it's really like a block and a blockchain that has code that executes if certain conditions are met. So like if you buy an item, then this code gets executed. That's what I understand a smart contract is. Yeah, so I kept going back between the ownership of that. So I think really the owner is defined in the transaction of the block transaction, not as a property of the weapon. Like I was saying, the initial owner would be a root or a bank or a marketplace, wherever you want your main account to be called. And really what you want to do, like if you really want this to be secure, like in a real game, like I said, this is just a proof of concept, but in a real game, you want to have public and private keys. So whenever you're sending these weapons from the bank, from your admin account to the player, it's all encrypted. And then the player would have private keys to prove that they are the true owner of this item. Here's the transaction. I already talked about this. From to item ID or currency amount. Here's where I'm showing the transactions in Unity right there. Already went over blockchain should be decentralized, not client server. But then you get into how are you going to keep all these blockchains in sync? I don't know. I haven't gotten that deep into it yet. But I'm thinking it's kind of like a peer-to-peer type thing. But I have never done a peer-to-peer program before. The closest I've ever done was Tetris, where I did a little network Tetris deal, which was a good exercise if you're learning to do networking. Just do a simple 2-player Tetris game over the network. Other applications, I was thinking, hey, I need to redo all my leaderboards with blockchain. That would be pretty cool. That way, you know, every transaction on the leaderboard is a valid transaction and it can't be changed. It's like once it's added to that blockchain for leaderboard, it's there forever. I thought that'd be a cool application. Okay, so as far as NFT marketplaces go, there are some out there. I really haven't really seen them applied to games. Closest I've seen is like people selling objects, and you can use that to like get an item in a game or something like that. But it isn't really, in my example, tying the purchase on one of these marketplaces to a specific item in a game. I think it's kind of like redeeming for an item in the game is all I've really seen so far. So I don't endorse any of these, but these are two big ones that I've seen lately is OpenSea, OpenSea.io, and Magic Eden, MagicEden.io. So if you do have cryptocurrency and you're kind of interested in what can I go out and do with that, and here's a couple of sites you can go to. I don't endorse them or anything. Not saying there's anything wrong with them, but I don't give financial or purchasing advice. But yeah, if you're just like me, just starting to learn, it looks like a good place to start. I was going to talk about some other blockchains. I'm not going to get too deep into it since this is all new to me. I'm kind of a little bit late to the game and all this cryptocurrency and all. But here's some example blockchains. One's Polygon. They use the Matic, I guess, coin or cryptocurrency. Their site is polygon.technology. You can actually go to polygonscan.com and you can see all the transactions, which I think is pretty cool. Of everything that's being traded. So I think most of these are just like people sending coin to each other. But there may be transactions for NFTs in here as well, or the smart contracts. Ethereum is another big one. I think it's kind of like number 2 right now. So that's at ethereum.org. You can go to etherscan.io, which is the picture here at the top, and see all the transactions for it. And the one that's been around for a long time is Bitcoin at bitcoin.org. It also has a site, I didn't put it on the slide, but it's mempool.space. There's a screenshot of it right here, and it's pretty cool. You can see all the transactions being verified, things like that. But the downside to Bitcoin, I think it's only for the Bitcoin cryptocurrency. I don't think you can actually do NFTs like or smart contracts or anything with the Bitcoin blockchain. So talking about blockchains, the next thing you're going to be aware of exchanges and wallets. I don't know how much this directly applies to games, but I could see if you do have a game and you want to use one of these marketplaces or NFT sites to sell the items within your game, instead of handling it yourself, then this is a way you can do it. So if you want to purchase something, an item, then you need to go to an exchange to get the cryptocurrency first, unless you mine it yourself. That's an option as well. But once you have your cryptocurrency, you can either have it on the exchange or have it in a wallet. And what I've heard from what I've researched, I've done is like the wallets are more secure because then you own that wallet. You own the private keys for that wallet. And one thing that you, like I said right here, the exchanges are for purchasing cryptocurrency, and the wallet is for managing your payment, your addresses. So one wallet contains multiple addresses. So if I want to send somebody cryptocurrency, I use one of these addresses, or if I want to receive cryptocurrency, I use one of these addresses. But you may not necessarily want everything on one address because all these transactions are public, so you can have multiple addresses in one wallet. And one thing that I've heard is to be aware of, your currency is not actually stored in your wallet directly. It's actually stored based on the transactions in the blockchain. So it's really not stored in the wallet. It's based on all those transactions in the blockchain. So your wallet manages your private keys. That's how it knows that you are you and nobody else can get at your cryptocurrency. And also, if you have it in a wallet, it preserves your cryptocurrency if the exchange fails or goes away. And like I said, you can send, receive, or purchase with your wallet address. Yeah, so I think that's enough. Let's see here. Yeah, so that's kind of like a crash course in exchanges, blockchain, NFTs. Like I said, I really haven't known much about any of this. I'm kind of learning as I go. But yeah, I do see an application where all of this can be applied to games. I think it's coming, probably. It just isn't there yet. So I think being on the bleeding edge of that is probably a good thing. Being ahead of the curve, learning how all this works. So anyway, hope everybody found it interesting. Like I say, I'm not an expert on blockchain. I'm not an expert on cryptocurrency. That's my understanding. So I could have messed stuff up, but that's my understanding of it the way it is. So hopefully everybody found it interesting and learned something. So appreciate everybody out there listening and watching.